I'm now in the ETemplate photo software, and we're going to process those photographs into a CAD design. So to start, the first thing I need to do is select the camera that was used for the photographs. I will then go to the directory where my pictures are located. There were 10 photographs in the video, and I'm going to use all 10 for the process. I select my photographs and tell the system to go. It is now automatically opening each photograph and scanning the image to find those markers. When it finds a marker, it's going to very accurately, again to 1/100th of a pixel, measure the center point of that marker. And then behind the scenes, it's going to also identify its code ring so it knows which markers are in which photographs. As we look at the photographs pop up on the screen, we see the little dots in the middle of the markers, and those are the center points that have been measured. On the right hand side of the screen, we see a dialog box that is giving us a brief summary of how many points it is finding in each photograph. Again, the system wants to see each marker in at least 2 photographs to triangulate, and it wants to see markers overlap between photographs to stitch it all together. And as you can see, it is doing all of this fully automatically. A very unique capability with this technology that I'll show you later is the ability to go back into the photograph and extract additional measurements without going back to the job site. Each photograph contains 500 million data points that we can extract information from. And as long as we can see a location in 2 photographs, we can make that additional measurement without going back to the job site. So we have a couple more photographs to process, and it will then begin its calculations. A user can run multiple projects simultaneously if they desire, or can be running under other programs while this is working in the background. The system is now running through all its calculations to define 3D positions for each of the markers. The system is 3-dimensional, so we can measure any kind of space, horizontal, vertical, even things like spiral staircases. All our points are measured, and I'll now tile the photographs. Right within ETemplate, we have a measure tool that allows us to select points to measure. So if I pick a couple points here, one on the bar top and one on the countertop, I'll be able to calculate its 3D distance as well as its XYZ distance. And we notice that that bar top on that end is about 5.94 inches high, approximately 6 inches. I can also measure points across photographs from one end of the room to the other. Besides measurements, we can also go in and view the points within ETemplate. I'll come in here and open what we call our viewer, and this allows us to look at our points in 3-dimensional space, where we can also come in here and turn on the actual camera locations to be able to view them in 3-dimensional space as well. And this allows us to see that the person has moved during the measurement process. Now once we have all our 3D measurement points, we can go into what we call our process center. And in here we can have standardized settings for your company. For instance, what do you like for overhang? What do you like for outside radiuses between finished edges, inside radiuses? Even wall offsets if you want to provide yourself some clearance for your installs. So the system is going to draw the countertop with those parameters. It will also tell us how flat the cabinets are, what the square footage of the countertop is, the linear footage of profile edging, and even output all the data in multiple layers for your CAD system. Now through the integrator, we're going to tell it we want to process a countertop and just preview the drawing. So with one button click, it has now designed the countertop with the overhangs, the radiuses, everything identified, even this table of cabinet flatness. If I need to modify something, I can come in here and select an edge and just change its value. For instance, if I want to make a 6-inch overhang, I hit OK, and it updates my drawing automatically. I can do this with any radius, any edge, even a wall. I can also identify specific information. For instance, here is a point that we want to identify as the minimum overhang for the bar top. And that information is now going to automatically be processed out to the DXF file. So I can go out to any CAD software, and I'll come in here and import this created DXF file. So here's our DXF file with all the changes we made, all the standard design parameters of the overhang and radiuses. And in the bottom left in red is our table of how flat the cabinets are, the calculation of square footage and linear footage, and again that identification of that point for minimum overhang up towards the right hand corner. Once the design is in CAD, you have full functionality to do any kind of additional modifications you want. I'm going to bring up here another design that allows us to look at this drawing with a few additional features added, such as the seams, the sink, and the bar top. So this is what it would look like after adding these additional features. What I want to do with our process center is be able to go in here and do what we call a back plot. And this is going to actually place the countertops back into the photograph. So I'm going to take first the countertop and process that back into my photographs. And I'm then going to take and process the bar top into the photographs. And I can now go back to ETemplate and look at my design with the actual CAD drawings plotted back onto the photographs. This information can be used both internally as well as showing a customer what may be some design problems, such as a sink being too large to fit in the sink base, an overhang too large to cause an interference with a door jamb, or an overhang of a bar top not being big enough to cover up a corbel. Think this might save on some customer headaches? So now I'd also like to be able to show you the ability of marking some additional points within the drawing. I'm going to turn off my design and come back in, and I'm going to zoom in on a photograph, and maybe the templater forgot to measure the sink center line. I'm going to come into these two photographs where I can see the sink cabinet and measure the center line with two different photographs. I now select the point in each photograph, tell it to reference them together, and then process to three-dimensional space. I can now go back into my viewer and look at that data, and if we zoom in, we can see we now have a new point at the midpoint of that sink base, which would be our center line. And we can do that without going back to the job site. Do you think that would save you some drivebacks? Well, right now you've seen the process with ETemplate, and I'd like to invite you to share this with others within your organization, such as the templater, the CAD designer, and management, to be able to see what ETemplate's all about.